All right. So question number one of the test is the mean value theorem. And I guess what we should probably start off with is talking about the mean value theorem setup. And there's pretty much just the one equation in the mean value theorem. And you're not going to have to memorize it or anything. It's written in the problem. But I know a lot of you don't like looking at equations, doesn't always click. Okay. So this is the main idea behind the whole mean value theorem question. Who should we go with? We should go with somebody. Cam, how about you? Do you think you could remind me what either half of this formula says? It is this, yes, it's the average rate of change. So this is the slope between the endpoints. Now, traditionally in the problem, you're going to be given an interval. And the interval will be like from A to B. They don't usually give you the endpoints. They usually just give you the A and the B value. So if they give you the A and the B value, you're going to have to find the endpoints. Oscar, what about you? How would I find those endpoints if we're given the A and the B? That's true. That is definitely true. What I was hoping you could tell me, how do you find f of A? How do you find f of B? Because you're not going to be told those. You're not going to have a table in the question on the test. I can tell you that. Okay, that's okay. That's why we're doing the review. But what you had said about the table was good. So you basically had said how to figure out A and f of A from the table. Anybody remember how to find f of A and f of B? Rather than me just calling on somebody. Yeah, go ahead. Oh, perfect. F of A is by plugging A into the equation that you're given. Well, so that would be f of x. So you have to be given an equation to start with. F of A and f of B are when you plug those into the equation you're given. Sam, what is f prime of C? Oh, go. Nope. So average rate of change is regular slope, like algebra 2 slope. F prime is the instantaneous rate of change. I'm going to guess that Khan Academy uses these terms a lot, probably, huh? Average rate and instantaneous rate of change. And that's not a bad thing to know or learn either. So Sam, I guess I was more interested about the prime. Like that little prime symbol should kind of like be key to tell you what it is. Oh, Sam. Oh, okay, that's all right. Marissa, how about you? Do you remember what prime, the F prime means? Okay, it's all right. Anybody? It does. It does. Derivative. Yeah. I mean, everything you had said, Aiden, was correct too. F prime means the derivative equation. So you guys should be familiar with the notation f of x, f prime of x, f prime prime of x. So if you ever see that notation written somewhere, it means the derivative. Now the last little detail here, although that detail won't matter on the test. So this isn't a free response question on the test, so I guess this detail doesn't matter. This will only matter on the AP test. The c means the derivative with a c value instead of an x. So on the test, it's a short answer. So you're basically just going to be writing number answers in there. So it really doesn't even matter what letter you use. So here's what you're going to be doing. You're going to be taking the derivative equal to algebra 2 slope of the endpoints. And this is what you solve for the mean value theorem. And whatever that answer is your answer when you're done. And obviously things can be very different throughout it, especially the derivative part. The slope on the right-hand side can't be really much different other than just how bad the numbers are. Now I can do an example if somebody has an example they want me to put up quick. Otherwise, my guess is you guys probably feel a little bit more comfortable with the mean value theorem than some of the other questions, but I could be wrong. That's what I wanted to reserve for today. Like I said, I'll just do whatever you guys ask me to, but I thought I would kind of go through each problem. So this is question 1 on the test. Should we move to 2, or does somebody have a question on anything we wrote up there? All right. I don't really have much room for writing today, so I kind of have to just... I guess if nothing, this is the beauty of recording, because I'm recording all of this, so even if you missed it, I will post the recording. All right, question 2 on the test. Find critical numbers. Please. Bella. Bella, do you remember what a critical number is? Perfect, but close. Nice, nice. That was the little extra part. Okay, now the derivative equal to 0, I think most of you guys have that part down pretty well. I think some of you get a little bit confused on the derivative undefined part. And I could be wrong. Eric, do you think you could kind of enlighten some people what the derivative being undefined means? Like 99% of the... okay, that's one way to say it. That absolutely is true. So an undefined slope would mean straight up and down. In terms of when you're looking at the equation, to know if there's a vertical asymptote, this generally means that you're going to have a 0 of the denominator. Now, there are other ways to be undefined, but a 0 of the denominator is like 99% of them. I mean, like you could have a negative square root, things like that too, but those most likely you would probably catch or see, you know, without much thought in it. Um, so we won't actually solve this. I'm trying to think of one off the top of my head that works. If you have a polynomial equal to 0, there's different ways to solve that. The most common way is factoring. But the factoring only works if you can factor it, right? I mean, like, that part's obvious, but so you're not always going to be able to factor all these. Some of them you'll have to, like, bring the number to the other side, cube root it, things like that. Factoring isn't the only way. Factoring is usually the most common for quadratics. Obviously, it can be for whatever. Chase, what would we do for the trig ones? How do we solve trig ones? How do you solve trig problems? Like if we get a trig derivative and we're trying to find critical numbers, what do you do for the trig ones again? I think some of you know, obviously. I just wanted to kind of, in case somebody forgot. Absolutely. That's probably going to be the most common method for most of you. So the trick for trig problems is make sure that you have the trig function equal to a number. If you have it set up like this, then the unit circle is a possible way to solve. But that's the only way to really solve trig problems, is to get them like that. Okay, so I wrote number 2, but this is 2 and 3. Who should we go with? Kennedy. If you are a betting person, and you're not because you're underage, why do you think I'm highlighting 2 different versions of the critical numbers? Okay, that's right. This is why I'm pointing this out. Does somebody know what I'm trying to say? Why am I highlighting? Oh, that's a possible good clue. Okay, so there's 2 critical number questions up here. There's a real good chance you're going to have different styles, which is the only reason I picked 2. So if they weren't going to be different styles, I wouldn't have you do 2 of the same type of question. So do know that when you are trying to prepare, don't only prepare one style. That's why I'm putting multiple things up here. All right, there's 2 and 3. And again, if somebody has a question they would like me to do, I can put it up here and do it. Otherwise, what I find is a lot of calc kids are way too reliant or dependent on me going over an outline or a review. And I feel like some of you guys think like a chapter review is supposed to be like some sort of, you know, saving grace thing that like all of a sudden will give you all of this knowledge. Where a review and an outline is supposed to be just kind of us polishing up little things that you might not remember off the top of your head. Relative extrema. Okay, before we do talk about relative extrema at all, I need to point out Mackenzie, what did I just draw up there? What is this thing? That was a really good explanation. That was very good. That was 100% correct. That had a lot of info in there. That's basically what question 4 and 5 are. So the relative extrema you're going to find using the first derivative test. On Schoology, I can't draw this thing. So the reason I'm trying to give you this important info, Schoology did not let me put this into the problem. It only let me make tables. So I want to show you how I wrote the first derivative number line as a table. Okay, I'm assuming I have a table. I've got to be able to put a table in somewhere. Insert a table. 1, 2, 3, 4 by 2. Well, it's not what I was expecting, but we'll go with it. Wait, I can't draw on it? Okay. I will, ooh, here we go. Good enough. We're not going to take too much time on this. Okay, a table. And so what I did was the question is going to involve the first derivative test. Draw that. So what I did on the test was I wrote intervals. So this section right here is the, so in a table I wrote negative infinity to negative 1. This middle section is negative 1 to 3. So this is going to be the same, just kind of presented differently, because that was the only way I had an option to present it. And this is probably actually quite a bit more similar to how a textbook or AP might present. So this same number line that I drew up above on the test would be written like this. Now, I don't even remember which number is which. Doesn't matter. One of the questions, I'm giving you the first derivative test filled out. And you're going to have to answer relative extrema from that. Ariana, if this was our, if you were given this, how do you go about figuring out relative extrema from that? Very good. Good. Very good. Thank you. So this spot right here, this is going to be x. It changes to decreasing. I know it's decreasing because it's first derivative. Decreasing to decreasing is nothing. So this is not a relative min or max. It's just nothing. X equals 3 changes from to increasing. Well, decreasing to your hands, or if you draw, decreasing to increasing would be a relative min. Oh, do I? No, I don't have that on. Chidera, how do I find the point right here again? That's what you said was correct. I mean, like, you kind of sound confused. I think you're partially trying to just, yeah, what you said is correct. So you need the y value. Now the way you're going to get the y value is plug 3 into the original function. Now, I'm giving you the original on the test. On this one, I just made up a table. So on the test, I'm giving you the original function, and I'm giving you a table. You're going to have to answer relative extrema from the table. And I can't remember if the question wants you to give the answer as a point or an x value. It could be either one. If it asks for an x value, answer 3. If it asks for a point, then you answer that. It just kind of depends on what you're being asked to find. Now, does anybody have any questions on this table? Because on the test, this is how all of the number lines are written. It was like my only option. Does this probably makes enough sense to you, I'm going to guess? Because it looks similar to a number line. The main difference is you're not going to have just those two numbers. You're going to have intervals written. Okay, you guys are awfully quiet. Oh, sorry, say it again. So do you mean like an asymptote? Like if the... You don't even need to then, correct. So what you're saying is absolutely correct, and that's because if you would plug the critical number into the original, it would be undefined. And in that case, it's not an actual point, and so it wouldn't be an answer. That's the main reason why you're normally asked to find points. Instead of critical numbers, you're asked to find critical points. Yes, because it breaks up the graph. Yeah. Yeah, it's an actual point. Correct. Point has to be I mean, it sounds dumb to say it like that, but a critical point has to be a point. Because there's a lot of x values that can't be points, but are critical numbers. Critical numbers break up your graph, and a vertical asymptote breaks up your graph, but can't be a point. Oh. In this case, -1 and 3 are critical numbers, because critical numbers break up the graph and are on the first derivative test and whatever. This would be the critical point. And correct, you're given f of x on the test as well, so you would just plug 3 in to get the answer. I think it's a very good decision that we're doing the test in the afternoon. I have a feeling tomorrow morning at 9 o'clock you guys would look a little zombies. And I don't think the test would go fantastic. Just think about last year. I had a 0 hour last year. Everybody was taking calc tests at 7:30. What would you guys do for that? I don't think you guys... Heck, I was a little blown away. I even got an Amazon delivery today at 7 o'clock. I was a little shocked they're up and out that early. Okay, my computer's going real slow. That would be perfect. x to the 4th, 2x to the 3rd. Okay, and find relative what? Min? Well, that's kind of weird they asked for that specifically. Okay, we can do that. Okay, so the first thing we need is the derivative. So we'd have 4x cubed minus 6x, and then we need to set this equal to 0 or undefined. There is in there. See, I'm going to factor out 2x squared. I'd be left with 2x minus 3. So 0 and 3/2 would be my critical numbers. So one of these two, if we have a relative minimum, and maybe I'll set my information up as a table just so you guys are getting more used to it. So negative infinity to 0, 0 to 3/2, infinity. And if I test my numbers in the derivative, this is x to the 4th. So if I plug negative 1 into my term, minus 6, so negative slope decreasing, equals 1 into my derivative, I'd get 4 minus 6, which is negative 2. Actually, this is like the same one that I drew. I plug 10, I'd get 4,000 minus 600, which would be positive. And are you guys okay where I'm getting the minus and plus signs from? By plugging in numbers in each section. Okay. Well, if I'm looking for a relative minimum, decreasing to decreasing is nothing. Increasing is where relative minimums happen. X equals 3/2. I have a relative minimum, but they most likely want the answer point. I mean, it doesn't have to be, but usually information is asked as a point. So I would plug 3/2 into the original function. Oh, God. Yes, I plugged, for whoever just asked if I plugged those into the first derivative, I took a test number from each section and I plugged it into the first derivative to get the minus and plus signs. What 3/2 to the 4th is going to be, God, this is terrible, 81/16 minus 2 times 27/8. I'm going to pretend I'm doing this in my head, and I'm just going to type it in. 81/16, 54/8. And change that to a fraction. And that means that I did this in my head, and I got negative 27/16. And it's possible. So Khan Academy has some things, not differently, but like, so Khan Academy might actually just even want the height of the relative minimum. And so it may want just this number. I wouldn't say that we're common, but that might be what they intended. Most places will ask for a point. What time are we at? Okay, we're halfway through the class. Are we halfway through the... Close. Some questions on the test are finding points. Some questions are just finding x values. So if I have you find an x value, it's intended for the question to go quicker, pretty much. Like I think one of these critical numbers is just to find the x values, not the critical points. So in that case, then you don't have to find the point. But on each question on the test, I made sure to write what your answer should be. Like I said, list the x values or list the points, something like that. I wanted to make sure you guys at least knew what kind of answer you're supposed to give. Okay, 6. Find intervals of increasing, decreasing. Hoovenik. I haven't gone with Carson. Carson, how do you find increasing, decreasing? I think you mean it correct. What values are you talking about? Okay, yeah, then you meant it correct. So you were talking about to find the values of the derivative. So the test is where you find out increasing, decreasing. If you're given a little table, that's a pretty clear. You can just ignore my artwork abilities. If you have a first derivative table, these plus and minus signs, first derivative, represent increasing, decreasing. If I remember correctly, I don't remember which question is which now, but questions I give you a table already filled out. One of them, I gave you, I think it must be this question. One of them, I partially filled out the first derivative table for you. Like what I did is I filled out the intervals. And then from this partially filled out table, you're essentially going to fill out the plus and minus signs. And then that would basically figure out where it's increasing, decreasing. So positive slope, increasing, negative slope, decreasing. Some of the questions on the test are absolutely intended to go fast. This is one of them. We'll go with it. It's a good graph. I like how I spelled where. Where is. So let's come up with, who should I ask? Who should I ask? I should ask Anthony. Are you ready? Maybe? You're ready. All right. Okay, Anthony, your question. We want f prime to be positive or negative? There's a lot of thinking for just, okay. Oh, I wasn't even asking a question. You're just deciding on your own. You're coming up with the question. Okay, do we want second derivative to be positive or negative? All right, good choice. Good choice. Okay, so if we're looking at this picture, Anthony determined that we are supposed to find where f prime is positive and f double prime is positive. Now, I need you to also use your imagination a little because my drawing skills are rough. This obviously is supposed to be a nice curve, not like a jagged peak. Okay. Kennedy, how about we go back to you? This question's definitely easier than the other one I gave. Where is f prime greater than 0? Do you remember what f prime represents? So it represents the slope. How can we tell where slope is positive? Greater than 0 would be a positive slope. That would be where your graph is increasing. Here, okay, so if you are asked to find where, that's talking about slope. Greater than 0 is where your graph is increasing. Oh, you know what? Let me write letters on here to make it easier for you. Okay, can you tell me where this graph is increasing? Because that's what we're looking for. F prime greater than 0. Just tell me between what letters it's increasing. That is a G. Up there is a G, yes. So here, from A to C, the graph is increasing because it's going upwards. Is that all right? Okay, so where else is it increasing? Perfect. Okay, good. Anywhere else? Perfect. Correct. Because C to E is decreasing, G to J is decreasing. Okay, good. So this is the first half of our problem. Alexandre, can you tell me where f double prime of x is f double prime of x is greater than 0? And if, do you want me to kind of guide you through that? Okay, f double prime represents concavity or curvature. Okay, if your second derivative is greater than 0, it's curving upwards. Most people think of it as a U shape. If f double prime is less than 0, that is Oh, go ahead. Okay, it's actually going to be from D to H. I absolutely get what you're saying, but from A to D is part of upside down U. And it's partly because my graph isn't very good. It's definitely because my graph isn't very good. The graph that's on the test, I tried to make it, I actually had the computer make it. So D to F is right side up, but perfect answer. Theoretically, H to J is concave up as well, because I can see that that's the left-hand side of a U. Now, is everybody okay with the shadings we've gotten so far, or does somebody want me to explain the purple or yellow? Okay. Your final answer is where the graph has both of these satisfied at the same time. In our situation, E to F would be the final answer. E to F is the only place on this graph where it is increasing and concave up. So you are specifically looking for where they're shaded at the same time. And you can do that in your head, or you can write it on paper and figure it out, whatever. On the test, this question is going to be a picture, and you're going to click on a marker and use your mouse to highlight the answer like this. So it's not something you're going to have to write or explain. You're just going to literally draw on the question. Okay, moving on then. Absolutely, you guys interrupt me and ask away if you have questions. Relative extrema using the second derivative. Ew. Okay. Who have I called? I have not called on. Oh my God, everything's going so slow. Jacob, did I call on you yet? Okay. So, if I draw an upside down U like that, or if I draw a right side up U, those actually came out so much better than I expected. what would the tip of each one of those be or known as? Do you remember? Oh, okay. That's very good. That's very good. So those would be critical numbers because they have a slope of 0. And because they are critical numbers, then exactly what you just said, so this one would be a relative max. This one would be a relative min. So you are given okay, I wanted to finish writing that, otherwise I was going to butcher it. If you are specifically given a critical point, so what I pointed to on those pictures, really bad pun there, I guess. So if you are given a critical point, and you know its concavity, you are kind of guaranteed that it is a relative min or a relative max. So let's say I give you the top situation. Could anybody explain to me how I know that's a relative max using the information shown up there? Let's give this a number. Let's say this is the 0.34. I would be able to say the 0.34 is a relative max because I'm told it's a critical point and it has a negative concavity. So you are going to be given a situation on the test, and I am going to be expecting you to be able to explain to me why it is a relative min or max. That's exactly what question 8 is. It says find relative extrema using the second derivative. So that's what this situation is. Now, we have talked about it before, but I also know some of you might get thoroughly confused if I just throw out that question, on its own in the middle of nowhere. That's exactly what question 8 is going to be asking for on the test. Okay. Come on. Excuse me. We got 10 minutes left. Nope. There might be one. There might be one of them that's multiple choice. They're basically all short answer. Except for 13. 13 is going to be an FRQ that you write out by hand and upload the picture of it in the question. So we've got 10 minutes left. Is there anything from 9, 10, 11, 12, or 13 that anybody would like me to do more than, the most, that you want me to talk about? Otherwise, I can just give you a really brief rundown. Kind of, yes. Here, this was the one we did in class, I believe. So you're going to be given something similar to this. You're going to be given 3 graphs, and then you're pretty much just going to be asked to identify which one is F, which one is F prime, which one is F double prime. And the way you go about doing that is you look at easy information. Oh, all of a sudden a bunch popped up here. What is the difference between relative max-min and absolute max-min? The difference between relative max-min is generally you're going to be asked a relative max-min when you have a graph that goes on forever and like an odd function points both ways, and the absolute max-min don't exist. So those would be relative max-mins in between. Absolute max-min is usually only asked on a closed interval where it has endpoints, and so that you could have a max or min. What are we doing tomorrow during class? Tomorrow during class, we are not meeting during our normal class time. I was only going to have you guys come in the afternoon for the test. I was just going to take attendance from that. That way I figured, you know, I don't want to take up a lot of your day. Now, I'm going to be on doing Khan Academy, like putting your scores in for Khan Academy during the morning. So I'll be on the computer, so if you have a question, you can write to me. Otherwise, I think I wrote the directions on Schoology today, what we're doing tomorrow. I think I did. Okay, I'll go back to this graph one quick. So the only locations that we know, the easiest, are slopes of 0. Like, I'll look at number 3 because that's probably the easiest to locate. 3 has a slope of 0. So if I were to draw its derivative would cross the same spot. Okay? Now, in slopes of 0 is a slope. So that means my derivative would be above the x-axis. This is a negative slope, so my derivative would be below the x-axis. This is a negative slope, so my derivative would be below the x-axis. So if I can find a graph over here that looks like that green one, then they would match up. And now this blue one definitely looks the same because they cross in the same spots and it's above and below in the same spots. So that would tell me that number 1 is the derivative of 3. I have to figure out how equation 2 fits in here, right? I have to figure out if equation 2 is the derivative of something or if it's like the original function. So I'm going to graph the derivative of number 1. Number 1 has a slope of 0 here. Should cross right there. Its derivative would have a height of 0. Oh, daily, I forgot to shut off the ringer on my phone. So if I look at the blue section right here, it is positive slopes. So the positive mean its derivative is above the x-axis. Negative slopes would mean its derivative is below the x-axis. I forgot this has a slope of 0, so the derivative would also cross there. So negative below the x-axis but has to cross again would go right there. And then that definitely matches up with number 2. So number 2 is the derivative of 1. So judging by what the information I found, judging by that, number 3 would be f. Number 1 is the derivative of 3, and number 2 is the derivative. I can go over 13 really quick. So that's what the graph in question on the test is going to be like. Unfortunately, I couldn't find one where the graphs were on top of each other, which works better when you can't physically write on the paper. So I couldn't find one like that. Oh, wait. Ha, never mind. I did. Erase what I just said. Look at that. Nice graph. The question on the test, all three of these would be on top of each other. Oh, God. All three of these would be on top of each other. And so you'll be able to compare them. You'll be able to compare them on top of each other to be able to see where they cross at the same spots type thing. So it would look something like, all three will be on top of each other. It'll be in color, though, so it's not going to look as confusing as that. But you'll be able to identify 1, 2, and 3 from that. Okay, so somebody wanted me to do question 13 really quick. Question 13, the optimization question. Optimization question. You're going to have a primary equation. And the primary equation is the one, and it could be anything. It absolutely could be anything. It could be area, it could be volume, could be distance, could be perimeter. I mean, like, it literally could be anything. It's whatever you're trying to maximize or minimize. On the test, I made sure that it's a shape that's very basic, so it's something you automatically know the formulas for. If you don't remember the formulas, you can look them up. Okay? So, your primary equation is what you're trying to maximize. Let's pretend we're maximizing volume. Okay? Your secondary equation, its only purpose is to be able to substitute variables. And it's traditionally going to be something with numbers, right? So like in the problem, you'll be given numbers. Like it'll say, I don't care, I'll just make this up. It'll say something like the two numbers multiplied is 500. Well, then what you would do is you would solve for x or y. And then you use this to substitute, make up equations completely, right? So you would use this to substitute variables and to help you solve the primary one. And then you take the derivative to find it. And that's how you'll be able to solve the optimization one. So there definitely is examples in Khan Academy. If you hate Khan Academy, you are more than welcome to actually use your textbook, which you probably checked out at the beginning of the year. Your textbook has tons of examples on optimization as well. You are welcome to search wherever. And in fact, if you go to YouTube and just Google, okay, I know those two terms don't go together. If you Google optimization for calculus, you'll find hundreds of examples. And if you want to watch YouTube videos on it, you could also search that up on YouTube as well. I know some of you are very concerned about optimization. I need you guys to realize that this is just one question on the test. It's not a majority of the points. Okay? I didn't set it so that optimization was majority of the points. I know on the last test we did, the FRQs were. And that's because we had more time to cover everything. So this is just one topic. So I made question 1 through 12. I think it's probably 2/3 of the points on the test. And then 13 is a third at the most. I mean, this is just me trying to remember it off the top of my head. Okay. Oh, geez, it's 10 o'clock already. Okay. I guess we're done for the day. Again, you are welcome to send me questions if you have some. I'll be on today from 1:15 to 2:30 for open help session. Tomorrow, we do not have class at 10 a.m. Nope. Chase, I actually managed to set it up so that the question 13 is directly within the test. And so you'll have to submit a picture or document within the test, which I know is more annoying. But it was the only way we could set it up because we have to do testing at different times. Good. Thank you for bringing that up. That I don't know, Lauren. So I took it and it went fast, but that doesn't tell me anything. Are you wondering whether you can take it during the class hour? Okay. Well, no, I mean, like, I don't care what time you take it. I don't know if you have other classes to do. So you can just kind of tell me when you want to take it. That's fine. I'll be on the computer at 7:30, so you can take it anytime after 7:30.